Hi, so I think we are live. We are live. Okay, so let's get started. Okay, hi. So my my name is Muhammad Sajeer. My name is Muhammad Sajeer. I'm doing my PhD in nanoscience and engineering at IISc Bangalore. So a lot of you have already reached me if asking if I'll be able to teach something. They are finding difficult in electronics and stuff. So I thought, okay, I will take few classes on electronics. So this is basically for physics students, basically MSc and BSc graduates. This will definitely help you to crack your electronics questions in net, gate, or jam. I mean, going through these lectures will be good enough, or I'm not saying that you'll be able to solve all the questions, but it will make you competitive, and this lecture should be good enough for you to understand the basics on electronic stuff and as well as solve these exams or crack these exams. So yeah, so am I eligible to teach you? That's the first question. Of course, I think I'm eligible. I cleared net JRF as well as gate and jam and everything, and I'm doing a PhD at IISc Bangalore, which is an institution for definitely none of you need an introduction about. So I'm good enough to teach, I guess. So I'll be teaching you electronics, basic electronics. I will build upon the fundamentals. I assume that you don't know anything in electronics, and we will build upon that to get the 100 percentage. 100 percentage. You will learn the for example 80 percentage, and that will be good enough for you to help you to crack all these exams. And one more thing, if you are from the premium side of the country, and if you know electronics, there's a good chance that you can get into companies like Intel or Western Digital or Applied Materials or Applied Material Science company, but or Taiwan Semiconductors. So there's a good chance that you can get into a good package if you are looking for a job. If you are looking for an industry job, you can easily get at least 20 lakh per annum if you know electronics better. So these lectures will help you for the same. So we will get started. Um, we'll be we'll first start with the basic electronic circuits like resistor, capacitor, and that kind of stuff. And after building the fundamentals, we'll go into higher. And I think this will be a good learning for you as well as for me, as I need to, I mean, brush. I will need to recheck. I mean, remind all this. I have forgot actually. I'll have to study again and teach you, and this will also a good exercise for me as well as you. So let's get started. We will start with why we need electronics. Why we need electronics. So electronics basically, or more than electronics, why we need electricity, and you know why we need electricity, right? It is used for everything. I mean, I'm teaching you just because there is electricity, and I was able to charge my computer, and I am able to teach you in that, and so on. And also, if there is no electricity, there's no bulb, there's no light, there is no. I mean, it won't be that great. Of course, something else will be there, but electricities have a very good high impact on our life as well as, yeah, that's it. Okay, so electricity is basically, so we are using electricity mostly because it is easy to transport, it is easily available, and it can be controlled very easily. You just need few resistance capacitors and all, and you can control how electricity behave. And yeah, that make electricity a good option to do the stuff and everything. And one more thing, one interesting thing is like if we have some problem, if we have some problems in one domain, if you know electricity, you can, if you know electronics and electricity, or not electricity, if you know electronics, you can convert that problem into an electronic problem, then solve it here, and then apply back. So it will make you, it will do it. I mean, this, if you know electronics, and if you are able, you'll be easily able to solve the electronics problem, and it will make your life easy. Okay. So in electronics, I mean, some of you may hear about the Fourier transforms, right? We'll take a math problem and change it to a Fourier space, and after that we'll solve the problem, and after that we will take the inverse transform and get the problem done easily. So it is something like that. We can change all our problems into electronics problem and solve it. Then we can, I mean, apply it back, and it is really easy. Some of you may think that electronics is not is a hard stuff. I mean, it is like taking a lot of time, and it is not something, not like I mean, your solid state physics or electrodynamics or something like that. But from my experience, trust me guys, electronics is easy. As someone said, everything is hard until you try, right? So everything is hard until you try. So let's try. Let's see how the electronics stuff are can. If you are able to grasp it, it is good enough. I'm sure that it will be easy to grasp it. I mean, it is not that much hard problem. Okay, so let's move on. In electronics, we have everything. I mean, the initially we had a triode. Then after that we come to then vacuum tubes. Old movie, I mean, old TVs and, I mean, old computers and everyone were based on vacuum tubes and vacuum tubes. There was some new brands like vacuum tube electronic stuff and stuff. So then we move it to transistors. Then we move it to in early 80s or 90s, 90, 50, something like that. And it was around, we have moved to MOSFET. We know MOSFET, right? I'm sure we have. Then we move it to microprocessors. Then we move it to MOS based ICs and everything. So this is the latest thing. 2020, we are reached at MOS based ICs, and like it is like 100 million ICs. I mean, not transistors in millimeter square area, and it's amazing. It helps you to get the job done. The previously the computers were in an entire building, and currently it is just like a, I mean, very small, and it is on a tabletop device. So electronics actually basically helped in doing all this stuff. So yeah, that's about the basics, and that's the introduction. And let's get started from the tools for electronics. To learn anything for you need tools, right? I mean, the basics things, you want to know. If you want to learn maths, you want to know numbers, you want to know differentiation, integration, and every that kind of stuff. So electronics also, there are some tools. So in the subsequent lessons, we'll be looking at the tools, what are the tools available, and how we can use that, what are the examples. And just if you already know this stuff, just revisit it. I mean, it will be good enough to hear again, and it will be good in here again. And otherwise, you can just skip this. But I would say you can just listen and see if something is missing, or you can have it something good thing. So the basic stuff, all your degree MSc people know that resistance is R equal to rho L by A, where it is resistance, it is resistivity, it is a length, it is the area. So this is the relation, and we all know Ohm's law, V is equal to IR, and we all know what is power, right? Power is equal to V into I, power is equal to IR, power is equal to V square by R. All these equations you have studied in your 10th and +1 +2 all these times. So these are the basic electronic stuff. So let's go to some circuits. Let's do some circuits and learn this. Okay. I assume that you don't have any basic knowledge. I mean, just the Ohm's law and everything, Then after that, we can easily build upon that. Okay. So before going to that, let me introduce some terms in electronics. So in electronics, some of you may heard about nodes. Nodes are actually a point where two or more circuit elements are connected. For example, if there is a resistance like this, if there is a resistance like this is we called as a node. If there is another resistor, there may be another resistor, there may be another resistor. Okay, these things are called as node. And I'm sure this kind of circuits you have seen in your +2 physics and everything. Okay. And that's it. So that's the nodes. And in a very basic fundamental law in electronics is you may have already have heard about this. It is KCL and KVL. So KCL is actually Kirchhoff current law. Current law. I'm sure you may already know what is Kirchhoff current law means. For example, if you have a node like this, if current is I1 is coming this way, I2 is coming this way, and if I3 is going this way, then I1 plus I2 should be equal to I3. That should be right, otherwise there is no logic in that. And current is coming this way, current is coming this way. If something is going in this way, like it should be sum of this and this. Otherwise, there is, I mean, something, nothing can be made from the vacuum. I mean, empty space, right? So plus I2 is I3 is a Kirchhoff current law, and there is one more called Kirchhoff voltage law. These are the basic laws in electronics. Kirchhoff voltage law. So what Kirchhoff voltage law is like? Let's have a circuit, something like a circuit like this. If we have A, B, C, D, E, okay, have a voltage across this which is called as VA, a voltage across this which is called as VB, a voltage across this it is called as VC, something like that. Then the total voltage in this loop, in this loop, you can see this, we'll consider it as a loop, and this loop it is like equal to. So the trick is when the voltage we are going from negative to positive, it is always negative. So the thing is like then minus VA plus, we are going from positive negative, right? So it is plus VB. Here we are going from positive negative, so it is plus VC. That will be equal to 0. So sum of voltages in a loop will be 0, and you have to make sure that you are properly given the signs. So this is about the Kirchhoff voltage law, and I just want to remind, I mean, just want to remind that when you go to positive to negative, is we will take it as negative. Then this will be good enough. I mean, when some problems comes in jam or something, is we need to remind that when we going to, oh sorry, it is from negative to positive. Okay, sorry, yeah, it is negative to positive, it will be negative. Okay, so that is about the Kirchhoff voltage law. And I mentioned about loop here. Here I mentioned a loop. Some of you may have doubts that what exactly a loop is. So loop is actually a closed path. It's like this. If you go this way, this way, this way, this way, this way, this way, it's a closed path. So the idea is like we should not go through any node more than once. That's the rule. So once you went through it, you cannot come back. Then you have to go through this way. So for example, these are all nodes, right? I thought more than 2 circuit elements combined, there is nodes. So you'll go this way, this way, this way, this way, this way, this way. Is it a loop? No, because you are going through this node twice, right? But if you're stopping here, then it is a node. I mean, it's a loop. So just think about what a loop is. If you didn't understand, just rewind this video and you'll get it. So that's about the loop. And yeah, let's move to another slide. So I'm sure you already know what is a series and parallel. I just mentioned that series is when circuit elements are controlled like this is series, and when circuit elements is controlled like this, these are called parallel. This considered like that won't work, right? I will just tell you the definition. I mean, when it is considered in series, there is no other elements connected to the node joining them. That's the rule. For example, here is a node. When this and this are connected, and the rule is there should not be no other elements connected. That means this and this are in series. For example, if there is another resistor connected like this to this node, that means it is not in series. Okay, and there is a parallel thing. Then we'll say parallel means like when two elements are connected in parallel, if both end of one element are connected directly to the corresponding end of the other. Like if you see here, this end is connected to the end of other element and this end is connected to the end of other element, right? And this end is connected to this element, this end is connected to other element. So both are in this and this are in parallel, this and this are in parallel. So this is about the series and parallel thing. I'm just reminding these things, and I know you guys already know this, but I was just reminding this. Okay. So yeah, I think that's the basics. We will see you in the next video then.